Current bridge design specifications, published by the American Association of State Highway Transportation Officials, employ the load and resistance factor design methodology. The specifications are used in the design, evaluation, and rehabilitation of bridges. A recently completed TxDOT research project, conducted at the University of Texas at Austin's Center for Transportation Research, has filled in some knowledge gaps in the spec through laboratory testing and proposed design recommendations for a special class of CTT nodes used in strut-and-tie modeling.
And bridge substructure is basically below what's the deck of a bridge. And in those disturbed regions, particular care is needed in designing and detailing bridge components. Over the years, research sponsored by Texas Department of Transportation answered a series of questions that helped simplify designs and ease the construction of such components, but then not all questions were answered. Open questions that were left it got answered during the course of this research project, and those questions relate to how to better detail the bridge foundations, how to better detail the column to cap connections. So these are the vertical components that we have below the bridge deck, and as they tie into the horizontal components that then support the beams that provide support to the bridge deck proper.
With all the past research done in Strut-and-Tie, we found that there were a couple of items that hadn't been fully fleshed out. This project has provided us with the knowledge to help us fine-tune the design of our bridge elements.
For example, we do have code limitations on what's called a crack control reinforcement. So reinforced concrete components are expected to crack under service loads, but having to manage those cracks, number of cracks, widths of those cracks, and so on, is done through the crack control reinforcement. The code limitations on the spacing of that reinforcement was done on the basis of scaled laboratory specimens, and we were able to basically push the boundaries and test at a scale that allowed us to relax the code provisions based on experimental findings without compromising the service or ultimate behavior of those bridge substructure components. So what does that mean? Simpler bridge details and savings associated with those simpler details in constructing bridges. So that's how the research project contributed to the overall design and construction on bridges within the state of Texas. And what we have done here is refine the understanding on bridge component behavior, therefore the design provisions that go with it, to where savings can be accomplished in structural details, simplicity can be leveraged in bridge construction, and therefore savings are possible in serviceable structures that are designed by bridge design professionals in the state.
We are always trying to improve the products we provide to the traveling public. And one of the benefits of this research is we're able to reduce construction costs on some elements and also improve reliability of other elements so that it's a more reliable, safer, and hopefully more cost-effective bridge.
For more information and to find the publication for this project, please visit the TxDOT Research Library at the link shown below.